The title of this video is The Mechanism That Had Formed the First Protein in the Early Earth Environment. The sea in the early Earth contained iron atoms. There was carbon dioxide and nitrogen gas in the sky. Time dependency on CO2 dissolved in water was estimated by the values of hydrogen ion concentration meter. CO2 is 1 atm, H2O is 100 cc. The values of pH are converted to the hydrogen ion concentration. The solubility of CO2 in water is large. The degree of ionization is 0.017. So, 98.3% of the dissolved CO2 is molecule. The solubility of CO2 decreases with temperature rise. Solubility of oxygen gas O2 is less 1/30 of CO2. Temperature dependency of the viscosity of water is the same as the solubility of CO2. Its activation energy is the energy of hydrogen bond of water. Reaction of iron powder with carbonated water is very slow. It was measured by using pH meter. The following movie shows that CO2 gas 1 atm and outside of water reacts with iron powder inside of the water. Left bottle, the water contains iron powder. Right bottle, the water contains iron powder and amino acids. Following movie were photographed at interval of 5 minutes for a single frame image. Components of the amino acids are glutamine, valine, leucine, isoleucine, ornithine, citrulline, glucosamine, and citric acid. CO2 gas 1 atm dissolved in water reacts with the iron. Large bubbles are formed in case of the neutralized solution, where membrane covers the surface of the water. The bubble is not seen in the bottle that contains amino acids. The amino acids have the effect to dissolve the membrane in the water. Although it takes time, the bubbles are formed even if it contains amino acids. Here, the produced solids together with water are stirred. Absence of a bubble is not absence of organic molecules. The atmosphere is changed to air from CO2. The air reacts with membrane at surface of the water. It is estimated that nitrogen gas in air reacts with amino group on the surface of membrane. There was a period in the early Earth where ultraviolet rays was irradiated and atmosphere was CO2. Seawater in the early Earth contained metal ions of iron and calcium, and molecules of ammonia and amino acids. The reaction between iron and carbonated water, that is CO2 and H2O, were photographed under UV radiation. The left bottle contained calcium oxide, and the right bottle contained amino acids. Atmosphere is CO2, carbonated water pH 4.7. The photographing is 5 minutes interval for one frame. The next movie shows change of the solution by CO2 of 1 atm. After stopped UV radiation and stirred the solution. It is estimated that calcium carbonate, that is CaCO3, is made from carbon dioxide calcium ions in the water. Changes were caused by addition of iron powder on the surface of the water. The iron powder neutralizes the acidity of the water. The life of the membrane that stays inside of water is long, because there is not stress in the water. Replay, in order to confirm the generation of vesicles in the water that contains amino acids. Experiment 1 on production of liposome. At first, large bubbles were emerged at surface of the carbonated water with iron powder in the sealed bottle after several hours from the mixing. Iron neutralized the carbonated water in the sealed bottle. The photographing is 10 minutes interval for 1 frame under fluorescent lighting. After 5 days passed, by stirring the liquid, the solid that was produced was dissolved. The hydrogen ion concentration of water pH becomes high by supplying CO2 from the alkaline state that was yielded by sealing of the bottle. In 1 atm of CO2, vesicles stay inside of the liquid. Life of the membrane that stays inside of the water is long. The photographing is 30 minutes interval for 1 frame. Bubbles and liposome are produced plentifully when the acidity of water became a neutral state. In order to confirm, replay again. The vesicles were disappeared. It is estimated that the peptide bond of amino acids was decomposed at the acidic state. As for formation of a liposome, a bursting bubble on surface of the water, it breathes water together with membrane on the surface. As for formation of a bilayer membrane of a liposome, the hydrophilic amino acid attaches to the both sides of the membrane. Interaction between the molecules that forms the membrane is the same. Large bubble is formed by coalescence of small bubbles. An action of coalescence is very quick. So, the speed of repairing the membrane is very fast. The operation to repair is carried out by the synthesis. The bubbles were repaired during heating of the bottle. Metabolism will prolong the life of the membrane. The long life of membrane inhibits decomposition of the peptide bond. Experiment on production of liposome. The first experiment is acidifying by 1 atm of CO2 gas from alkaline state due to iron powder. Liposome was not produced because there is not amino acid. Replay again. Amino acids were added for the second experiment. Adding the amino acids into the water that contains iron, and stirring it. After that, leave it in the air. Acidic state by CO2 gases gradually changing to an alkaline state by iron ions. There are 2 layers between the surface and the bottom. The layer was disappeared by hit the bottle. the hydrogen ion concentration and synthesis of protein. The bond of amino acids such as peptide bond is changed on the acidity of the water. As for the solubility of amino acid, although amino acid is soluble in water, it is insoluble in oil. The side chain of the amino acid is concerned with the attachment to membrane. As for synthesis of protein and the thermal motion of amino acid is suppressed by the connection to the membrane. It suppresses the degradation of peptide bond. As for synthesis of primitive surface protein, the bond of amino acids, that is, a protein enhances robustness of the membrane. Prolong the life of the membrane supports the synthesis of new protein. There exists a bubble with complex structure. This bubble is made from the carbonated water that contains powder of iron together with small amount of calcium carbonate. There is a layered arrangement of bubbles. Lifetime of the membrane that stays underwater is long, because the stress is lesser than the surface. Neighboring atoms of liquid have been swapped by thermal motion. Atom possesses an adaptability to the other atom, that is, a state of electron varies by neighboring atoms. Protein changes the form depending on the circumstance. The logic of reaction is, if A equals B, then X equals Y. Each reaction possesses selectivity. That is, the reaction occurs when the conditions are satisfied. Since thermal motion is reduced by synthesis, the synthesis is accelerated. Since thermal motion increases the decomposition is accelerated. The membrane with protein has been evolved to improve the survival in its environment. Conclusions. It was verified that a membrane was made from carbonated water with iron, and the primitive protein was made by amino acids those attached to the membrane. Thank you for your attention.